Alright, this question. T equals that. So that's what I'm going to write down. We're going to have to do some bit of algebra, a bit of maths. We'll see. So T equals A times, where is it? 2 to the power of Kn. So that's what it tells us. So that's what we've got there. Now, what happens is it tells us that when it first started, there were 1.25 thousand drivers. So I'm going to take this, I'm going to say this N, I'm going to change it to 1.25. Okay, so that's what we've ended up with there. Anyhow, now the other thing that happened is when this doubled to 2.5, the amount of time taken also doubled. So that's what we're saying there. Now what we're going to do is we are going to divide one of these by the other one. So we're going to say that divided by that. Got a bunch of equals. I'm going to delete this. Now, if we were to take this thing and divide it by this, the t's will cancel and the a's will cancel. So we'll be left with 2 equals 5.65. Let's start some deleting stuff. Divided by that. Then becomes that. So now from there, what we do is we solve. Whoops. That. Going to delete this. No, we can leave that in there. We're solving that for k. K is 0.8. So that's what we've got there. So that's the steps you take. Alright, so the next one. Show that a equals 8. So, if that's what k is, then we're solving for a. So now what we'll do is we'll define this. Define t of x as this. But instead of, we're going to write x, and we're going to write 0.8. Now they don't want exact answers. How long? 16 minutes? Alright, doesn't matter. Okay, so that's what we're doing now. So t equals that. Okay, now that's what it's telling us. Now we're solving for a. Initially it took Sam 16 minutes to get to work, so t of 0 will end up with a. So solve t if t of 0 equals 16 for a. That makes sense. Something times 2 to the power of 0. Okay, now we've got this situation here. We're saying that if x equals 0, so we've got 2 to the power of 0. So let's write this out. A times 2 to the power of 0.8. We're going to multiply that by 0. 0. Oh no, initially it took Sam 16 minutes, so we've got 1.25. Sorry, my mistake. Solve that equals 16 at t equals, whoops, 1.25. There we go. So it's equal 1.25. We have 16. Takes 16 minutes. How long does it take Sam to drive to work if the population of drivers is trebled? I think that means multiplied by 3. So if we say So we can say T of 1.25 times 3 should be 8 times A. So now let's redefine our function to 8 here. And let's do this again. Should take him 64 minutes. That's horrible. Okay, it says only concerned about pollutants being released in the atmosphere occurrences, also about the fact that as population grows, so is the amount of litter. This is starting to result in an increase in pollutants getting into the water supply. The amount Q pollutants of the T years and in the suburb is given by this. Okay, and how much did the amount of pollutant per litre increase during the first 5 years that Sam has lived there? So what we're going to do, we'll define Q of X equals 0.8 minus 0.45 times 3 to the power of negative 0.25 x. 25x. Okay. How much did the amount of pollutant increase during the first 5 years? So we're going to say Q of 0. So first 5 years, we're going Q of 0, Q of 5. So we're going to say that minus that, and we say it's increased by 0.3360. No, 3 decimal places. Okay. Let's get a graph of that. So let's define this. So we're going to redefine this between 0 and 10. X 10. I'm going to change this to 0. Oops. And now we're going to sketch it. And we're sketching Q of X. Q X. So that's what we've got there. It doesn't really go up by much. So menu, Windows zoom, Windows settings, -1, we'll go to 12, -1, we'll go to 1, and there we see it. Sketch a graph, label endpoint so we know that this is a 0. So endpoint here, let's see if we can do a minimum. Let's graph minimum, 0.35, and analyze graph maximum, 0.771. So we want 3 decimal places. That's given us 3 decimal places. Here, we substitute x of 0. So let's see what we end up with. Q of 0 when it was 0.35. Doesn't. That's just it. Won't get anything else. Okay. After how many years since Sam moved to the suburb will the amount of pollutant per litre double? So how long will it take for the thing to double? Okay, so what we want Qx equals 2Qx. So we're going to solve Qx equals, how long will it take to double? So 2Q naught equals Q of X, comma X. I'll take it 5.47 years to double. We want to go to 3 decimal places. So 5.476. That's how long it's going to take to double. So let's have a look at that on the graph. We're starting here at 0.35. We want to go to 0.7. 0.7. There it is. And it looks like it should happen at about then. So let's analyze graph. Intersection 5.48. And we were told 5. Yeah, close enough. Okay, last one. What pollutant level does this predict? What pollutant level does the model predict the water supply will approach? And so 0. Hang on. from the equation, 0.8. That's what it's saying it's going to approach. So it will never reach there, but that's what it's going to approach, 0.8.